Hey, hope you had a good day. Today we're going to talk about combining transformations into magic. So what if we want to do? I want to do like I want to rotate and I want to scale this thing. All right. Because right now with passing in matrices into one uniform, I can only do one at a time, right? I can only do translation, or I can do scale, or I can do rotation. What if I want to do both? So one way of doing that is to let's pass in another matrix here. So I'm gonna do so we're gonna do scale, scale, and we're gonna do U rotation. Let's actually get rid of this. Yeah. Okay, so I'm gonna do a vec4 pose. So I'm just gonna save this vector 4 in a variable that we can change. And then I'm gonna do pos is equal to U scale times pos, and then pos is equal to U rotation times pos. All right. So here I'm doing, I'm making the position to speed the position from the input vertex, and then adding the 0 and 1 to make a vector 4, which as I said before, required to do matrix multiplication. Then I apply scaling, and I saved the scaled vertex, and then I apply rotation to the scaled vertex. All right. So then I'm applying scale, and then I'm applying rotation, and then I'm gonna pass that into GL position. So I'm not gonna do this anymore. I'm just gonna pass pos in as GL position. Don't need to compile. And so let's get a reference to both of these uniforms, shall we? So I'll do uniform scale is U scale, and then U rotation is U rotation. So I'm getting the handle to both the scale and the rotation. I'm just going to comment out this translation here, and so we're going to set scale to U scale and rotation to U rotation. So I'm uploading the scale matrix to the U scale uniform, and I'm uploading I'm uploading the rotation matrix to U rotation. All right, cool. Let's see what happens. Great. So now it's scaled and it's rotated. Great. And we scaled by 2, so if I scale, if I scale by something else, if I scale by 0.2, so it's gonna be super tiny. It's gonna be a little baby. There we go, it's a little baby. It's a little baby. So itchy back. So that's one way of doing it, by just multiplying the vector and then saving the vector, and then multiply it again by some other matrix and so on. There's definitely one way of doing it, but one of the big powers of matrices is that they can be combined into one. They can actually hold sort of the transform of several concatenated transforms. So what do I mean by that? Well, I can make one model matrix. So that's going to be like the model of all, the matrix of all the model transformations I want to do in one matrix. It's going to be translation and rotation and scale in one matrix. And I can just do scale matrix times rotation matrix. Whoops. So if I multiply two matrices together, I am combining their transforms together. All right, it's a little bit more nuanced than that, but for now, let's just think about it combining. Okay, I'm combining scale with rotation. All right. So now if I upload this model matrix, it should do the same thing. Whoops, I removed it. It should do the same thing as me just multiplying the two matrices like this individually. So I'm gonna actually remove this again and go to U model. So I'm gonna let's just do that first. I'm gonna make one model uniform matrix 4, and I am going to umodel times vec4 a position 0, 1. So now I only have one matrix, the umodel matrix, and I'm just multiplying that with our vertex. And I'm just gonna combine whatever I need to do into that umodel matrix, so it will always contain all the transformations I've done up to, up to whatever. Cool. So let's make a umodel, and let's remove that. So remove this, and then I will just upload that. So let me just copy this actually. Sorry if it's going a bit fast. Umodel, it's gonna upload one, not transpose. We don't care about that, what it is. There we go. So we're doing umodel, and we are uploading that. This scale times rotation becomes this model matrix, and then we're uploading that into the umodel uniform, and then we're applying that to the vertex in the shader. Cool. Let's see what happens. There we go. We have successfully combined scaling and rotation into one model matrix. How cool. So, great. So now we have scaling and rotation. So let's just pop transform into that as well, translation into that as well. So just to remind ourselves, what's the translation matrix look like? Let's check it out. So I'm just going to do translation is equal to translation. No, sorry, model matrix. That's what I'm doing. So I'm just going to change the model matrix to only be translation for now, just to check it out, to remind ourselves what it is. Okay, it just moves it out by 0.5, so it should be to the right. That's our translation. So let's just try to rotate it. Okay, let's move it out and rotate it by 45 degrees. So I'm just gonna do rotation matrix times translation. Let's see what happens. Okay, so that's kind of weird. It like went up to the right. Let's move it out a little bit more just to make it super. Let's just do 1. And let's actually also make the rotation 90 degrees. So we expect it to just be flipped 90 degrees like that. Okay, so we moved it out by 1, but it's up there. So why did it go from being to the right like it should be to going up here? And I want you guys to really think about this. You remember what I said last lesson? A rotation matrix rotates around the origin. Okay? Not around the center of the mesh. Around the origin, 0, 0, 0. That's where it rotates around. So what's happening here? Why is it up there? Well, think about this. Let's actually do the sort of the process in Paint. So here's our NDC square. I'm just gonna write that out. There's our NDC square, rectangle, and here's our vertices, all right? In the middle somewhere. And the origin, I'm just gonna write that out. The origin is here. Right smack dab in the middle. 0, 0, 0. So first we translate, and here's where it becomes kind of obvious that the order matters. All right. First we translate. So it's gonna move to the right. So it's gonna translate by 1. So it's actually gonna end up here on the corner. So all the vertices are gonna move to the right by 1. So that's gonna end up being at the corner of the NDC square. So here's the middle of the Here's the middle of the mesh. Here's the new quad by moving by 1. Then we rotate 90 degrees, and the rotations happens around the origin. Remember that? The origin is here, so it's going to take each point as a vector from the origin and rotate that 90 degrees like that. So this is going to swing over like there. This is going to swing over here. No, actually, no, it's going to go over here. Yeah, there we go. So that's 90 degrees. This vector here, 90 degrees. Like so. Keeping the length. And the same thing is going to happen for each of them. So this is going to be rotated 90 degrees over here, and this is going to be 90 degrees over here. And what's going to happen is, here's our square now. What happened was we rotated all the vertices around the middle of the screen as a pivot point. So that meant we sort of swung around and ended up 90 degrees over here. So order matters. Order, oops, matters. That's what really is important in this lesson. I want you guys to take away one thing, and that's order matters. So how do we know the order? Well, this is also sort of implementation specific. What is the order here? Because I said it was just combining by multiplying. But actually multiplication has an order. One is applied to the other in one direction. And the way it works is that it goes from right to left. In OpenGL, I'm going to say that. In OpenGL and GLM, it goes from right to left. And that's unfortunately engine specific. Remembering exactly right to left doesn't really matter. The order matters. That's just what I want you guys to take away from this. If you work in, Unreal Engine and you see that, clearly this has happened where instead of moving or rotating and then moving, instead you happen to move and then rotate, then okay, I gotta switch the order up because the order was wrong. And you remember that that's the important point, not that you did the multiplication from right to left or left to right. It doesn't really matter. But I'm just going to say, in OpenGL and GLM, the order is from right to left. So first we translate, then we rotate, and then, we do whatever. Then we do whatever comes left of that. So to get the result we expected with, it being over here and 90 degrees rotated, we got to swap these two around. We want to first rotate and then move each of the vertices over. All right, so first we want to rotate, then we want to move it over. So we're gonna do translation times rotation matrix. And this will result in having first rotated 90 degrees around the middle point and then moving it over one. And now we're over at the right side that we expect, but flipped 90 degrees. Cool. So, great. What if we animate this a little bit just to make it a little bit more pleasant to look at and a little bit more fun to work with? So I am going to make my matrices over here instead. So I'm just going to move all of this into the tick or the loop. And we are gonna, we're always gonna translate by 0.8. Let's do that. But let's rotate by time times 180 degrees. Yeah, let's do that. And then I'll upload that. So I'll do this. Translation times rotation matrix. Yes, that should be good. Yeah, okay, there we go. Let's see what happens. Woo! Okay, that's a little bit fast. Still 90 degrees. There we go. So here's, if you're working on engine, this is kind of what you expect. You expect when you move something in a 3D engine, you expect it to stay there. You don't expect when you change the rotation for it to swing around the origin. That doesn't really make any sense. So in a game engine, translation is done last. You know, rotation is always done before translation. Otherwise, when you change the rotation of the object, it's gonna fly around. Because if I do rotation last and do translation first, order-wise, not multiplication-wise. Now I can see I'm not changing the translation. I'm not changing the position of this quad. That's constant. That's 0.800. It's constant. But still, it's moving around. And that's because we're applying the rotation after we apply the translation, all right? And if this happened in your engine, it would be very confusing. Cool. So, yeah, that's gonna be the conclusion of this lecture, and I'll see you guys next time.